All telephone numbers are preceded by a 3-digit area code. In the original Bell telephone system of assigning area codes, the first digit can be the number 2 to 9. The second digit is 0 or 1. And the third digit can be any number but 0. So 2 to 9 is all the options. I'm picking one of them, right? Do I need to box and hold? Does it say I can't repeat any numbers or anything like that? No, so I'm good. So how many are 2 to 9? 8. I'm going to tell you right now, if you write 7 because you don't want to use your fingers, that's actually way more shameful. I'd rather you go 2, 3, 4, 5, 6, 7, 8, 9, 8. Like I use my fingers all the time because I want to double check, triple check, because I'm not getting this wrong, because I don't want to go like this. Like I will 100% do that, and I feel great about it. Like, yay, 8. Okay, 0, 1. I didn't really do that. How many is that? 2. That was funny. No one laughed. Cool. 1 to 9. How many? 9. When you multiply that, you get 144. B. We. Messy. Okay. A password for a certain computer program needs to be an arrangement of 4 characters consisting of letters and digits from 0 to 9. So we have letters, there are 26. Digits, 0 to 9, there are 10. Remember I told you always read everything. They don't put anything extra in the questions, okay? Sometimes if it's like my daily quiz questions, it might have a little extra. But the practice diploma questions and the diploma questions do not. Okay? So I know I'm sitting here with an option of 36 options, maximum, right? That I can put in each blank, technically. Now I got to read. If the letter Y is considered to be a consonant, that means that A, E, I, O, and U are the only vowels. There are 5, and then there are 21 consonants, right? What is the number of 4-character passwords that either begin with a consonant or have no consonant at all? So they begin with a consonant or no consonants, right? So if I begin with a consonant, how many are there? Why did I add the 2 cases? Or. It says or. Or is add, and is multiply. And add don't go together, right? They fight each other. They're too similar. Okay. Is there any restrictions on these 3 blanks? No. So it can be all my options. And what are all my options? How many are there? 36. So 36, 36, 36. It doesn't say I can't repeat, so repeat away. Then this one says no consonants at all. So I have to kick out all the consonants. Now, it's easier to think, hey, my total number of options I have to choose from is 36. I have to take off the consonants, right? How many am I left with? 15. Or you could say, hey, there's 10 digits, there's 5 vowels, that's 15. Either way, you get 15, right? So it's 15, 15. I don't want a Java update. Java life. Tell me what I want. What is this computer now? Really? Right? Probably can't even update. It's a really old computer. Okay. And this is D. We agree? We. Okay. This one says an airline company requires flight attendants to wear a pair of pants. I'm going to underline it because I'm going to pick 1 pair of pants, 1 shirt, 1 tie, 1 blazer. Can I use the fundamental accounting principle if I pick 1, 1, 1, 1? Yeah. What if I had made them wear 2 pairs of pants? Super weird, but could I use the fundamental accounting principle? No. Then I would have to use something else. You don't know how to do that. You will. But you don't right now. Okay. So I'm picking 1 pair of pants. How many options for pants? 12. And then shirts. How many? 5. Ties? 4. And blazers. 2. Now sometimes on the diploma and on tests, what will happen is they'll give you how many pants, how many shirts, how many ties, maybe don't tell you how many blazers, but they tell you the total number of outfits, right? So then you would put in 3, 5, 4, X equals the total, and then just solve it like an equation, right? Take these, multiply them together, and divide them, right? It's not crazy complex, all right? What does this work out to? 15 times 4 times 2, 120? Yeah. This one says a 3-digit number. What if it said code? What's the difference between a digit number and a code?
Number can have 0 to start.
Number can have 0 to start, and a code? can. A code could be all zeros. Like I said, people are breaking into your bank account, but you could go 0, 0, 0, right? So this one says less than 400. So what are my only options? This is my restricted one. Less than 400 and a 4, 5. So this is be less than 400. What number options do I have? 1, 2, and 3. So I have how many? I am choosing 1. Then I go to this one because I deal with restrictions first. How many options? What about the middle? Any restrictions? So what do I have? 0 to 9, which is 10. Multiply those out. Make sure you get those dots checked. Everyone, make sure you're putting those multiplication dots, right? If you're not, go back, do it again. 3 times 10 times 2? 60. Told you to skip 5 because you only know it after today. Then this one says, how many even 6-digit numbers? I stop reading and I'm going to get it wrong. I have to keep reading, right? How many 6 even-digit numbers are there without repetition? So I'm going to have to box and hold, right? And I have even, repetition is kicked out. So what do I have to make sure I do?
Like 2 different cases.
2 different cases. One case ends in A.
0.
And one case ends in A.
2, 4, 6.
2, 4, 6. Now this is the catch. Could I do 6 cases? No, that's a lot. Could I do 5 cases? I could make it end in a 0, then make it end in a 2, then make it end in a 4, make it end in a 6, make it end in an 8, and it would get you the same answer. Ridiculously long amount of work, but it would still give me the same answer. I could actually do a different case for each of those numbers. So this is a 0. I box and hold the 0. How many options? 1. Then this one is 1, 2, which is 9. Hold the 9. Then 2 to 9, which is 8. That's 2. Whoop. I held the 9 and put 2 to 9. Anyone else scared by that fact? I'm the only one? Cool. Okay. 1 to 8. Let's try. Box the 8. 1 to 7. 7. 1 to 6. 6. 1 to 5. 5. Now this one ends in 2, 4, 6, 8. Who do we appreciate? Mrs. Lepp, Mrs. Lepp, Mrs. Lepp. Not even, like a couple smiles. Guys, I did one of these. Okay. 4. This is a tough crowd. Not going to lie. I was going to take my show on the road, but I think I'm going to have to not. I'm going to cancel it. So no one's laughing. All right. Just stay teaching. No problem. 1 and then 3 to 9. Why can't I put a 0 here? It would make it 5 digits. Yes, you were right, but I was translating. That took me a bit, which is exactly what I told you yesterday and earlier. You just said what I said, but that took me a bit to listen and put it in. Good talk. Okay, I'm still once again scared. None of you? No. You guys laugh when I just scare myself. Okay. 1 and 2 are out. What is left? 3 to 9. Plus a 0. Bring the 0 back. We're not bringing sexy back, we're bringing a 0 back. Yes? Okay, I got a couple of tables. I might still go on the road. Okay, 3 to 9 is 7. 3 to 8 is 6. And 3 to 7 is 5. This is the weirdest picking. Like, why did I pick? I don't even know why I picked. Anyways, cool. Good talk. We can check these and see if it makes sense. Every single time we box something, we should be able to look and say, is that actually an example of what they want? They want a 6-digit even number. So let's check them out. I have 9, 8, 7, 6, 5, 0. 6-digit even number not repeating. Would that be an actual example of a 6-digit not repeating, ending in an even? 9, 8, 7, 6, 5, 0? Yeah. Would this be an example? 1, 0, 9, 8, 7, 2. Yeah. So you can double check when it's a box and hold thing. Does that example even make sense to what they want? Now, when you multiply these out, you get the answer on the backboard if you didn't notice until right now. 68,880. Go team. Okay, let's go to our notes. I made it up, so no. They really just care about like your actual math about it. So we're on factorial notation. Okay, cool, we got time. All right, so factorial notation, we talked about it. It was like, we did 7 factorial, and that wasn't like a 7 screaming. It wasn't like 7, like an exclamation point. It means, that was funny as well, thank you. I'll be here all day. 7 times 6 times 5 times 4 times 3 times 2 times 1, done. Right? That was what 7 factorial meant. So how did we actually do it? We started at a number and we went down by? Rocket counting. Yes. We went down by how many each time? 1. See, what happens is I ask these questions, and then I imagine the answer in my head, and then I realize my question could be answered in a different way when I get all the answers that I didn't imagine in my head. Because your answer was correct. It's just not what I was thinking. So 7 factorial, we start at this number, whatever number is listed, right? And then we just go down by 1 number each time, which means we're subtracting 1 technically every single time. That's all we're doing, right? Subtracting 1, writing a new number. Subtracting 1, writing a new number. Correct? Now, if I gave you this, 7 factorial over 4 factorial, I could simplify it. I could expand my 7, 7 times 6 times 5 times 4 times 3 times 2 times 1. I love this box here, it's all the time random. And then I could expand the bottom, 4 times 3 times 2 times 1. And then what could I do? Anyone know? Yeah.
Can you just cross out the 4s, 3s, 2s, and 1s?
Exactly, because it's multiplication. When everything is multiplied, you can cancel top and bottoms. Anything in the numerator cancels anything in the denominator, and you learned that in rationals last week. So, 4, 4, 3, 3, 2, 2, 1, 1, and my answer is 42 times 5. What's that? And I get an answer, right? How could I represent this in a different way? You guys are making me question someone's math. My ears are old. So I just copied it, and then I was like, questioning it. But I was like, I'll just, and then you all go quiet. You want to know? I'm going to explain to you. So this is how I know something is wrong. You don't speak. None of you. At least for the first few weeks. Quiet. A little creepy. But anyways, this is what happens. I write something down, and everyone's like, and then when I write something down wrong, you all just like slowly write it, and then do this. And I'm like, okay, faces are telling me things are wrong. So you all did that, and I was like, something's off. So you could speak, or you can just show me your faces. I can figure it out. It's okay. So 210. Now, I could write it without expanding the whole thing. How I could do this, and I'm choosing numbers because we're going to use variables in a second here, is I could go 7 factorial over 4 factorial, and I could go, leave the 4 factorial on the bottom, and get the 7 to match it somehow. So I'm going to go 7 times 6 times 5 times what? 4 factorial. 4, 3, 2, 1 is just 4 factorial, right? So I could go like this. And then I could do this. Oh boy, didn't mean to do that. Thought I had a pen on the back. Do not. And then I get 210, which is a great answer. Actually correct. Crazy that happened. Okay? Now, what if it's variables? Now the variables, the reason why we're learning this now is we're going to learn to use these formulas over here. It's the permutation formula and the combination formula, and they look like that, right? But we're going to learn how to just deal with that rather than learn how to do permutations, get the equation, fill it into the equation, and then be able to solve it. That's a lot of work to try and do in one little brain step, okay? So instead of doing that, we're actually going over how can I just solve something like this without knowing what a permutation is, a combination is, or filling it into the formula. Because next you'll just learn how to fill it into the formula, but you'll already know how to solve this, so it won't be overwhelming. Okay? All right. So, now, if I have n factorial, not 7 factorial, I have n factorial. We agree? All I'm going to do is when I did 7 factorial, I started with a 7, went down by 1, put 6, subtracted 1, put 5, subtracted 1, put 4, subtracted 1, put 3, subtracted 1, put 2, subtracted 1, got to 1, and so on. Right? With a variable, what I'm going to do is I'm going to start at that variable, whatever it is, factorial. Then I'm going to subtract 1 and write it. Then I'm going to subtract 1 again. Well, that's n minus 2. Then I'm going to subtract 1 again, n minus 3, and I would just keep going. And I'm going to keep going because I don't know when 1 exists, right? Because I would technically need to know what n is to stop it. If n is 100, I'm going to go 100, 99, 98, 97, 96, 95, blah, 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 1, right? And then there's some more numbers going down by 1, right? But when we have n's, we don't know what it is. So we just start at n, go down by 1, right? N minus 1, subtract 1 again, n minus 2, subtract 1 again, n minus 3. Okay? So we're going to practice simplifying. So here it says simplify the following expression. Leave the answer in product form where appropriate. So do not expand. Product form just means when you have two factors side by side and you don't expand them. So if you have two binomials, you normally would FOIL with your acronym, right? We're just not distributing them. We'll just leave them as brackets for now. So we have to decide which of these is the bigger one. Is n plus 2 bigger or n?
N plus 2.
N plus 2. If you don't know which one, put a number in. So I'm going to put in the number 3 for n. 3 plus 2 is 5 factorial. This would be 3 factorial. So this one would be bigger because it would be 5 factorial, right? Just put a number in for n. That's Mr. Clay's maps. Welcome. It's fun. Oh. So n plus 2 is bigger than n. So we write the n factorial on the bottom. And then on the top, we expand the n plus 2 until we get it to match the bottom. So we can count. So if I have to expand n plus 2 factorial, I start with n plus 2, if it lets me write it. And then I do 1 less. What's 1 less than n plus 2? N plus 1. And what's 1 less than n plus 1? If you take 1 off of n plus 1, you get n. I know you all know the answer, but everyone's whisper answering right now, and I can't follow their whispers. And then I stopped and put a factorial. Why did I do that? Because it does what to the bottom now? It gets rid of it. It matches it. It can cancel it. There's so many good answers. Those are all true. Cancel it off. Done. So for this one, all I'm doing is literally just cancel. Okay. That's it for this. That's it. You guys try B. I'll help you out first. Which one's bigger? N minus 2 or n minus 1? N minus 1. If you don't know, put a 3 in. N minus 2 is 1. N minus 1 is, 3 minus 1 is 2. So the bottom is actually bigger than the top, right? So which one are you expanding? The bigger one. So which one are you expanding? The top or the bottom? The numerator or the denominator? The bottom. I just gave numerator and denominator and I got an answer of bottom. Yes. So on the bottom, we have n minus 1. What's 1 less than that? N minus 2 factorial. Now, when we cancel these off, they're just lines, right? They're actually not just lines. They're slanted whats? I feel like you're going to be the switching person from my other. This is going to be great. They are slanted lines. It's true. That's not what I was going for. They're just slanted whats. Do you know? Yeah. Nope. How'd that ask last week? When those are slanted, what are they just? They're slanted ones. They're slanted ones. That's all they are. They're slanted ones. No one's okay. They're just slanted ones. Anytime you cancel something off, it's just a slanted one, right? So, and the reason why I do that every single time is then you remember to keep the 1 in the numerator and you don't just get rid of it. Because when you cancel things off, you've done this before. If you had 7/7 back in your, I don't know how that just changed to 2 different colors. If you have 7/7 back in your day, you would cancel this and cancel this, and you would say it is a 1. The reason why is it's 1 over 1, guys. It's just 1 divided by 1, which is 1. Those slanted lines are literally 1s. The reason why I write them as slanted 1s is because then you won't forget to write it in the numerator. The numerator doesn't just cancel off and go away and be a 0. Okay? So in the numerator, you'll be left with a 1, and in the denominator, you're left with n minus 1. You could leave it in brackets like this, or you can just literally write it like this. Both of those are correct. What is not correct is if you get rid of the 1. If you're someone who got rid of the 1, you are star, 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 starring this answer, and you're like, girl, please, don't get rid of the 1. Yeah? If you just write them as slanted 1s, I promise you, you won't get rid of it. Because they are just slanted 1s. That's all they are. Those crosses, those little slashes, are just slanted 1s. That's all they are. Does that make sense? That would stay as a 1 on the top then in the numerator? Because it's a 1 left behind. Okay. And this would be n minus 1 times 1. Well, when you multiply anything by 1, it just stays that, right? Okay. For C, we'll expand the top because it's the only one with a factorial symbol. So we're left with n, 1 less is n minus 1. Now this is what I get when people do this. They do this, don't do this. Do this, don't do the next thing. Stop, put your pencils down if you're going to do what I'm going to do and it's wrong. They will go like this. You literally have this. Like that's what it is. It's not even math. It's just like a little squeal. Did I just record that? You're welcome. Didn't mean to. Okay. So that's an exclamation mark, and it's not English, right? Like that's what that is. That's all it is. If it doesn't have a number in front of it, it is not a factorial symbol. In order for a factorial symbol to exist, it has to have a number or a variable in front of it. Does it currently? No. So I actually have to keep going and not do what I just did. So I told you to put your pencil down. Whoop, whoop, whoop. Okay. So what I actually need here is I need to go one more, right? Because I need to have a variable or a number with the factorial symbol in front of it. So I can't cancel yet. I have to go one more. N minus 2 factorial. And now I can cancel them off and I'm left with something with a factorial symbol in front of it. Does that make more sense to you? Like if you're just left with an exclamation point, the hint to you is go one more. So the answer to this one would just be n minus 2 factorial. Now this one is different just because it's set equal to something. So this is where we're going to go here. We're going to go to algebraically solve. Could you just throw some random numbers in for n and get it to work out to 42? Yeah. If it says algebraically solve and you do that, you're getting a 0. An answer when it says algebraically solve means you actually didn't algebraically do nothing. That's what you did. You algebraically didn't. That's what you did. Okay? So if it says algebraically solve, I have to see algebra. Algebra is not your calculator. Algebra is like mathematics that is not guessing and checking. Guessing and checking is the opposite of algebraically. So if you fight me up and you're like, fight me up. I don't even know what that is. If you fight me on something, you bring it to me and you're like, hey, Lepp, I showed work. And I'm like, dude, that ain't algebra. That is guess and check. So if it says algebra and you give me a guess and check showing work, I'm be like, that is not the same thing. And then we're going to have a little discussion, and I'm going to win, because it isn't. But we might have a little battle. It's fine. I'm okay with it. But I hope we don't. I hope you just read algebraically and you algebra. Awesome. Okay. So we have this. We're going to go n factorial over n minus 2 factorial, which looks a heck of a lot like above, equals 42. 42 is a lovely number. We're going to just let it sit and roll for a little bit. Here, we're going to try and simplify this, right? Which is bigger, n factorial or n minus 2? N factorial, so that's when I'm going to expand, right? Till it matches the bottom, because I want the factorials to get out of my life. So I have n minus 1, n minus 2 factorial, and then I stop because it matches, over n minus 2 factorial. Right? Is everyone following me on that one? Now, we're going to have some slashes. This is a slanted line. It is also a 1. This is a slanted line. This is also a 1. You guys have been canceling since like elementary school. You didn't know those were 1s? That's the saddest thing. Or the best, because they just taught you something really cool, right? You can go home and tell your parents. That's what I learned today. They'll be so happy with you. Excited. Good. If you have a 1 in the numerator, do you have to write it? If you have a 1 in the numerator, do you have to write it if that's all that's left behind? Yeah. So, example, if I have this, 4 over 8. See, you didn't think you did this in elementary. Watch. You totally did. You just didn't know you were doing it. This cancels, gets cancels. I'm left with a 1 in the top and a what in the bottom? Slash it, I'm left with a 2, right? So could I just say this equals 2? No, what does it equal? 1 over 2. I have to put the numerator 1 if there's a 1. We agree? Because that's a half. But if I go this way, 8 over 4, and I cancel this and I get a 2, and I cancel this and I get a 1, do I have to write 2 over 1? Can I drop the 1 if it's in the denominator? Yes. Can I drop the 1 if it's in the numerator? No. And fractions just solely explain why that is not what you do. Okay? So, can I drop this 1 in the denominator? Yeah, because it would just be over 1, and I proved right here I can drop it. We agree? So I'm going to be left with n, and if you don't know, keep it. You go n minus 1 equals 42 over 1, and then you might be like, okay, well, I could just multiply the 1 up, it would go away, right? Like if you don't notice if you can keep it or not, you could just keep it. And now I bring the 1 up and it goes away, right, by multiplication. I'm going to get rid of it. Now, grade 11, and this is the catch. A lot of people aren't going to struggle with the 30 material. Every single 30 level question, except for in this unit maybe, ends with either grade 10 math or grade 11 math. So some people don't struggle with the new grade 12 math, they struggle with finishing with the grade of 10 and 11 math. So, if we have to finish with factoring and you don't know how to factor, don't go to denial, go right to acceptance, come in at lunch and say, Mrs. Lepp, I can't factor. And I would say, cool, I won't judge you. We'll just do factoring for 5 or 10 minutes and you'll be able to factor, right? Don't deny that you can't factor. Don't deny that you can't reduce a radical. Like, I don't care if you can't. I do care if you hold it in yourself and you don't tell me and I can't help you and I can't fix it. Okay? 5-10 minutes at lunch, you will be able to do any grade 10 and 11 skill that you couldn't do. I promise. You'll be able to do it like that. It would have been hard in 10 and 11. It will no longer be hard. Your brain's mature. It's just way easier. You'll be shocked at how easy it is. So if you don't know how to do something from 10 and 11, come in. I'll show it to you and you'll be able to do it in 10 minutes. I promise. Okay? Like if you don't know how to do a quadratic formula, come in. I'll show it to you. You'll be able to do it in 10 minutes. I promise. Okay. So we get to a skill and I say it's an 11 or 12 and you're like, I can't do it. Just come in. Or 11 or 10. Come in and I'll help you. So what did we have to do here when this was an 11? What was your next step? Distribute the n in. So we distribute the n in. Oh my goodness, I keep forgetting to have a eraser on the back. Distribute the n in, and I get n squared minus n equals 42. Then what was your next rule? Whenever you had a squared variable and another variable, you always have to do something next. Yeah.
Set one side equal to 0.
Set one side equal to 0 every time. If you forget, the quadratic formula up here hints it to you. If you look here, this is your formula sheet. I'm going to give you one. It goes, this has to be in the form ax squared plus bx plus c equals 0 or I can't solve. It literally hints to you how to do a quadratic. Right? It has to be equal to 0. You can't factor it if it's not equal to 0. You can't use a quadratic formula if it's not equal to 0. It has to always, every quadratic has to be equal to 0. So I'm going to get n squared minus n minus 42 equals 0. Okay. So I have a 1 in front of my n. And I go, what times what equals the outside? Now, I know this looks foolish. You're like, I don't need this little lines of multiplication and an addition sign. I am way too cool for that. If you don't. It doesn't matter to me. People won't make mistakes if they do it this way. And it's a lot less brain power. So this is how I do it. So I go, what times what equals the outside? So what times what equals 1 times negative 42? So what equals negative 42 when you multiply it? And what plus what equals the middle?
Negative 7 and 6.
Yeah, negative 1. So it's negative 7 and 6. And then I can double check. Negative 7 times 6, negative 42. Cool. Negative 7 plus 6 equals negative 1. Cool. I won't make a mistake. Okay? Oh, I would like to go back to teaching grade 10 and doing factoring. It just brings joy to my heart. All right. So, if I have a 1 in front, do I have to do decomposition? Do I have to do the brackets and break it down and do all that hard work? No. When you have a 1 in front, you actually throw a party in your head because it's really easy. You can go to the next step right away. So if you have a 1 in front, a positive 1, not a negative 1, if you have a positive 1 in front like I have right here, I can go right to brackets. I get n minus 7 as one of them, n plus 6 is the other. Does it matter if it's n minus 7, n plus 6, or n plus 6, n minus 7 if they're flip-flopped? No, the commutative property of multiplication, and that's when you have brackets touching each other, that's multiplication, says this is the same as this. 3 times 2 is the same as 2 times 3, right? So it doesn't matter. These just have variables in it. What's our next step? Set each of them equal to 0. N minus 7 equals 0. N plus 6 equals 0. N equals 7. N equals negative 6. Now this is the catch. If I plug them back in, do they both make sense? So if I take the 7, remember you should always check whenever you solve, you can check. Every single time you solve, anywhere in any mathematics, you should be able to walk away being like, yes, I got this, or cry. There should be no in between. Like you yay, or like, oh, because you can check it and it equals or it doesn't, right? So if I plug the 7 back in here, I get 7 factorial divided by 5 factorial, right? Technically, like I could check this, so I would go 7 factorial over 7 minus 2 factorial equals 42. Then this would be 7 factorial over 5 factorial equals 42. And then I could go 7 times 6 times 5 factorial over 5 factorial equals 42. Or you can type it in your calculator. Either way, 42 equals 42. I can check. Every time solved, I can check. I can be happy. Yes? Yes. So this one is good. Mr. Clay's maps. They're my favorite. His maps are the goat, Tegan. His maps are the goat. All right.
They're the gorilla.
Yes. Okay. So if we plug negative 6 in here, I get negative 6 factorial. That was me stopping. You didn't. That was breaks. Negative 6 factorial you can't do, because factorial symbol says I start at the number and I go to 1, correct? Negative 6, if this is 1, where I'm standing, where's negative 6? Yonder. So does that work? No. You actually can't have a negative factorial. When you can't have something, when you get a solution and it does not work, what do you do?
You cancel
Extraneous. So there's a difference between no solution and an extraneous solution. An extraneous solution says, I got a solution, it don't work. No solution means I tried to get a solution, I can't get one, it's no solution. So an example of that last year was when you filled into the quadratic formula and you got a negative under the square root symbol. Then you would get no solution because you can't take the square root of a negative number, right? This one I got a solution, cool, it can't work. It can't, my English, subpar. So we circle it, we put a line through it, because it did exist, right? I want to show that, I don't want to put a cross from an equal sign. I want to show, hey, here it is, it doesn't exist, and then I have to say extraneous. And then if you do this, anyone marking your question is like, man, these children rock. Like 3 out of 3. You are the best. Like that's what they're thinking, like genius child, right? Okay? Circle line through it extraneous means I got a solution, it doesn't work. Does that make sense? So we're going to go to the next page. You have a little bit of questions. We're going to bypass that. So you have 1 ABC and 2 AC. Bless you. Bless you. And you can now do number 5 on your quiz. Remember how I said don't do number 5, you can't do it? Actually, don't worry about number 5. Ignore that. Check that. We'll do that on this. Just do these. And then if you look down here, here's answers. Don't just write answers. If you just write answers, I'm going to be like, there's no work, you just cheated. Okay? Don't be that person. Try this. 1 ABC, 2 AC.